Hello, good morning, good afternoon, good evening. Hopefully not middle of the night for you. My name is Tom Kirk and I'm at OPAL-RT Technologies. It's my pleasure to be the host of today's webinar. It's a really exciting webinar, of course, a very hot topic that a lot of folks are interested in. So it's obviously a pleasure to be bringing you this webinar with my co-hosts and our amazing presenters. So if you haven't seen this already or learned about ADAS, you're going to be really happy about this webinar on how digital twins are used to develop ADAS systems. So I'm going to quickly present who's presenting today, and then I'll explain the structure of the webinar. But we have three presenters. The first one is my colleague Hervé Pollard, who's the general manager at OPAL-RT STI. This is a division of OPAL-RT that opened in the last year. It's based in France, and it's specifically dedicated to the simulation and testing of intelligent transportation systems. So that's going to be our opening presentation. Our second presentation, it's my pleasure, we're going to be hosting Didier Wautier, who since 2016 has been the head of AD simulation and virtual reality department at Renault. So obviously that's exciting to have the perspective of someone who's working at an OEM. And lastly, it's my pleasure to introduce who will be the final presentation, Gilles Gallet, who's the business development director, AD and simulator at ANSYS, who is probably well known to most of our attendees because they're a huge player in all sorts of simulation, but they are also involved in this field of ADAS. Okay, so quickly before we begin, questions. Everyone has questions. How does that work? In your GoToWebinar panel, you're going to see a little section that's called questions. You can submit your questions in that area or in the chat if you can't find it. We may not be able to take every question, but we will do our best. And if we cannot, we will get back to you via email. So with no further ado, I'm going to show you the structure again. And I'm going to pass my presentation rights over to Hervé, and we will begin.
So thank you very much for this introduction, Tom. So I'm Hervé Pollard. I'm managing director of OPAL-RT Intelligent Transport System. I'm in charge in OPAL-RT to develop all the business and the product for OPAL-RT on the intelligent transport system and more focus on the autonomous driving system. So today I would like to share with you how in OPAL-RT side the digital twins are used to develop the autonomous driving system. First, I'd like to introduce you the state of art of the autonomous driving system. So as you well know, we have to integrate multiple new technology. We have the new sensor like LiDAR and camera, but the new technology like data fusion with or without artificial intelligence and the V2X communication. So we need to test and validate all this new technology together. Not only to have the safe solution, but to show to our customer and our driver that the new cars are safe. To be sure that the new cars are safe, we need to validate with the same objective than a real driver. For that, some statistic data announce that we have to test on 14 billion of kilometers. So you understand that today the simulation and the digital twin are the key of the autonomous driving success. As you understand, with the previous slide, we need to change the development and the testing methodology. You have three different phases of the development. The phase one, the objective is to record all the different cases for autonomous car. We have a huge number of petabytes which has to be ingested and stored. Don't forget that an AED car can generate up to 1 gigabyte of data per second. So we need to store all this data and prepare it for the artificial intelligence training. And of course, for the component and system test of the autonomous system. In the phase two, we develop and test the multiple ADAS functions. For that, we need to train the artificial intelligence function or develop it in other languages. To train the artificial intelligence, we have to use the tag data from the phase 1, or for the edge cases, we have to use the simulation in the closed loop. Of course, the end of this phase 2 is to test the algorithm with brokered data in open loop and the simulator in closed loop. The last phase is a phase 3. We have to develop the AD system for the targeted car. For that, we have to integrate the different algorithms on some issue, like ADAS issue, of course, and, for example, brake or power steering. We have to build the model for each ECU component and build the AD system with the integration. Now, thanks to the previous slide, we have to validate the AD system to confirm the functionality and the safety. You understand that we have to simulate millions and billions of scenarios selected and built in the phase 1. We need to launch on cloud. Before to put in cloud, we have to build the digital twin of the AD system in the simulation platform. When the AD digital twin is available, we launch it on cloud with a selected scenario. And after that, if some fault appears, the analyst download it from the cloud, the third scenario, and analyze it on the simulation platform. At the end, the AD model or the software is validated, but it's not finished. We have to validate with the real controller and have to test on P-HIL bench. OPAL-RT decided with some partners to help our customers on different phases with a big focus on the phase 2 and the phase 3. In this AD simplified architecture, the car is in environment. So we have the reader, the pedestrian, if you are on the street, the building, and the other car. All these things has to be detected by the sensor, for example, camera, radar, and LiDAR in this presentation. This sensor sends all this information to the ADAS ECUs through different protocols like LVDS, FlexA, or Automotive Ethernet. The ADAS ECU makes some data fusion and understands its environment in real time. Thanks to different situations and information coming from all the other controllers, the ADAS ECU can activate braking system or accelerate the car by sending information to the powertrain ECU or braking ECUs through a CAN communication protocol. Then, the braking and powertrain ECU activate the different electromechanical systems like powertrain or brake. You understand that we built a digital twin of the ADAS system. Most of the software proposed to build this platform with a connection between their software and MATLAB Simulink. This solution is okay if only you need to make a model in the loop test or development on the component level. Next is the validation of the system level, and you need to have a high representativity of your different components. In some cases, each component teams are using different software to build the component model or the electromechanical system. We switch to this solution. As I explained, in some cases, the model comes from different teams or departments on the same company. And we think in OPAL-RT that you need to use the best software to develop and validate your AD system. Here I take the example of our partner ANSYS, which has a really good software to simulate the environment, the city weather, and of course some complex sensors like camera and LiDAR. This simulation software has to be connected to ECU model developed in Simulink. In most cases, the protocols like CAN or CAN-FD is modelized in CANU from vector and the closed loop. And to close the loop, we have to put the powertrain model and dynamic models. All these models are the component of the AD digital twin. For that, we have to connect all the signals together, synchronized, and have no impact on the behavior of the component level. OPAL-RT proposed Orchestra, which is based on software RTLab. First, RTLab software is a software in charge of the modelization, the compilation and execution of your model in real time or not on multiple type of platform. You will be able to run your model on different technology like ARM, FPGA, or GPU. In the left, you see the RTLab workflow for the integration of the MATLAB model. The strength of RTLab is to be able to cut the models in different blocks and optimize it for the fast simulation. Orchestra is a co-simulation add-on of RTLab. Orchestra is an application-level data communication layer and an high-performance simulation framework. Thanks to this flexibility, you are able to plug and play your different software through a XML file. Orchestra has the capability to exchange a high volume of data between multiple software on different platforms. This performance of Orchestra will be described in the next presentation of Didier Botti. In the next two slides, I will show you the functionality sample of RTLab Orchestra. You will see how RTLab is flexible, easy to use for the model management. On the left, you have access to all the connected platforms, real-time and non-real-time. You have not a limit of number of targets which could be connected to this platform. After, you have the Model Explorer. In this part, you have the tree of your integrated model. You have the capability to manage the internal signal of each model. Now you can select each model on which platform you want that your model run, the type of simulation and the time step. Of course, you can manage the execution and the result of all the model during the simulation. Then, during the simulation, you can check the performance of each system and subsystem of your model and other things like data logging. Thanks to this information, RTLab gives you the capability to put your model on different courses. It's a processing core assignment. Then you have the connection panel where you can connect the model together or graphical interface. The second slide shows you on the main component of RTLab and ADAS is the data recorder. On the left, you have the list of the multi-core recorder implemented for each model, and you can manage the name and the list of signal inside it. In the green, you will have the list of recorded files generated at the end of the model simulation, and in orange, show the recorder configuration where you specify the recorded time or size of your file, the format of the file, and the trigger configuration. And in red, you have the list of the recorded signal for the selected recorder. As you understand, OPAL-RT proposes a software and hardware platform. This platform can be used at different steps of your development process in open loop. OPAL-RT provides, for example, the platform on the left with the capability to read the multiple type of recorded data and to inject it inside your digital twin platform. Then, in the middle, you can train your artificial intelligence function. But after, you need to develop your fusion data model and validate the behavior of the camera issue, for example. For that, we propose the same platform in the middle with more GPU and CPU power. Thanks to their experience solution, you have a high representativity of the sensors model and make a lot of tests on the edge cases. We will have the presentation of Gilles Gallet just after that. Finally, you need to understand that we could have, so you need to understand what kind of impact the ADAS system could have on the driver. So we can use the same platform to connect it to a steering wheel and pedal. In addition, with this platform, you will be able to prepare your driving simulator for some tests and replay in case of problem or failure. And the OPAL-RT understands that it's really important to test on millions of scenarios. So we decided to deliver RTLab Orchestra compatible with cloud solution For that, we propose a batch version of RTLab that you can use with all the cloud providers. RTLab can run on multi-session mode in parallel, and thanks to that, you are able to launch thousands of AD digital twins in parallel on cloud. Of course, in case of failure, or just for analysis, the AD engineer can select the recorded data, the digital twin platform, and the scenario based on cloud, and launch the digital twin on its own platform just to modify, to validate, and to understand the behavior of the failure on the problem. At the end, we have the P-HIL platform. So we have to validate the real ECU. For that, we develop our partnership to integrate the best one solution in the market. So thanks to this close collaboration between NI and SIS, OPAL-RT is able to provide a large variety of products. If I take the example of the camera injection, the controller needs some information from the camera. If you need to validate the heat lamp functionality of your system, you need to have a huge representativity of your camera. And with over-the-air injection, you won't be able to test it. Then, for some other functionality, you don't need to have a high representativity of that. So OPAL-RT will propose this functional injection solution. OPAL-RT use an NI platform for the connection with the ECU through automotive communication protocol or digital input-output. And OPAL-RT proposes the same hardware platform able to run on the environment model in real time and synchronize with other systems. The key for OPAL-RT is to provide a real-time synchronization for open and closed-loop solutions. As you understand in my presentation, OPAL-RT provides RTLab Orchestra and this new platform or P-HIL solution. Thanks to this huge number of cores and the high performance of its GPU, you can use one platform during the full development of your project. This platform is dedicated to the autonomous driving test for all your AD development. So thank you to participate to this presentation.